I don't know if this is a review or an introduction to polynomial long division. Before we start dividing with polynomials, let's remind ourselves how we divided with real numbers. It may have been a while since we much of the time use our calculator. So if we wanted to divide 5 into the number 1,182, remember we would first look at this first term, 11. 5 goes into 11 twice, so we put the 2 there. And then we multiplied. 2 times 5 was 10. We would write the 10 down here and then subtract that value, so change its sign. Okay, 11 minus 10 gave us 1. And then we dropped down the next number. So now we have 18. And we'd say, okay, 5 goes into 18. How many times? It goes 3 times. And then we multiply. 3 times 5 is 15. We write that down here below our 18. And we change the sign. 18 minus 15 is 3. And we go ahead and drop the next number down. Gives us 32. 5 goes into 32 6 times. And we multiply. 6 times 5 is 30. And we write that number down here below our 32. Change the sign. 32 minus 30 is 2. We don't have any more numbers to bring down. So remember, this 2 was called our remainder. This is the part that was left over following division. And notice that we could also, what this means is that 1,182 is equal to 5 times 236, because that's how many times it went in, plus 2 more. Okay, that's what it actually means when we do division and find remainder. We're now going to translate that into doing polynomial division. So we do similar things. The first thing you want to do is write down your division problem. And one thing you want to check is to look at each polynomial, the one you're dividing and the one you're dividing by. Make sure they're in order from highest degree to lowest, which this is fourth, third, second, first, and then no exponent. Okay? And if there's anything missing, you would put a 0 for it. This portion didn't have anything missing, so I go ahead and write it down. 6x to the 4th minus 4x to the 3rd minus 5x squared plus 2x minus 8. Okay. On the outside, again, I look at my term, make sure it looks okay. Notice it's 2x squared minus 3. It's missing the x. So when I write down my division problem, I'm going to put a 0x there. Okay. So you write down any of those things that are missing, and then we go ahead and divide. Now this looks a little different than our regular division, but you still compare the front terms. I would say, what do I need to multiply times 2x to get it to equal 6x to the 4th? Well, to get 2 to be equal to 6, I would have to multiply by a 3. And to get x squared to be x to the 4th, I'd have to multiply by an x squared. So I have 3x squared, and I multiply that. I just distribute it. 3x squared times 2x squared is 6x to the 4th. 3x squared times 0x squared is 0x to the 3rd. Or excuse me, 0x is 0x to the 3rd. And 3x squared times negative 3 is negative 9x squared. Now remember, in our division, what we did is subtracted. So one thing one of my math teachers taught me is you draw the line, change the sign. So we change the signs of all of these terms that we just put here. And then we go ahead and combine 6x to the 4th minus 6x to the 4th cancel. A negative 4x to the 3rd and a 0x to the 3rd just gives me negative 4x to the 3rd. My x squared, I have a, that looks like 39, but I'm fairly certain it's just 9. Okay, negative 5x squared plus a 9x squared is a positive 4x squared. Okay, and then we bring down the next term. So we have negative 4x to the third plus 4x squared plus 2x, and we want to go back and start dividing again. So we go back to our front term and highlight it, 2x. I want to know what I have to do to get it to divide into negative 4x to the third. Well, 2 times what would give me negative 4? That would be a negative 2. It's hard to see up here. Sorry about that. I put it too close. And what would I need to multiply by x squared to get x to the third? Just an x. I'm going to double check that when I distribute. Okay, negative 2x times 2x squared is negative 4x to the third. Awesome. And then to the next term, negative 2x times 0x is 0x squared. And negative 2x times negative 3, our last term, is a positive 6x. Again, we do our subtraction, so we draw the line, change all of our signs, and then combine our terms. The 4x to the third cancels. This front term should always cancel, or else you multiply by the wrong thing. And then we have a 4x squared and a 0x squared, which is giving me a 4x squared. And 2x minus 6x gives me a negative 4x, and we bring down our final term up there. And we go one more time, and we say, okay, what do I need to multiply to get 2x squared to be equal to 4x squared? Well, 2 times 2 would give me 4, and I already have the x squared, so all I need to multiply by is 2 to get my 4. Let's check that when we distribute. 2 times 2x squared is 4x squared. 2 times 0x is 0x still. And 2 times negative 3 is a negative 6. Final time, we draw the line and change our signs. Negative, negative, and this would become positive. 4x squared and a negative 4x squared is 0. A negative 4x and a 0 is a negative 4x. And negative 8 plus 6 is a negative 2. Okay? There's nothing more to bring down, and x squared won't go into 4x because it's larger than that. It has more x's. So this is our remainder. This is what we had left over. So our answer looks really weird, but we got the answer is 3x squared minus 2x plus 2 with a remainder of negative 4x minus 2. Now, they are going to ask you to write that in terms of multiplication like we did up here. So our answer for that would be that our original problem, 6x to the fourth minus 4x to the third minus 5x squared plus 2x minus 8, that's what we were dividing, is equal to 2x squared minus 3, that's what we divided by, times our answer, 3x squared minus 2x plus 2, plus an additional negative 4x minus 2, or you can just put negative 4x minus 2 on the end there. Now, I know this is super new, okay, so we're going to do a couple more, so don't get too frightened yet. It's the basic steps that we do with real numbers when we divide, but it is a little different. Okay? All right, let's try this one. Use polynomial long division to complete each division problem. So again, we're going to do polynomial division. So we put our division sign. When we write down our terms, we check to see if anything's missing. And this one I have a third squared first degree constant, so nothing's missing there. Okay. Check what I'm dividing by. It's missing the x term in the middle, so we're going to put x squared plus a 0x plus 3 here for our division purposes. And we go ahead and divide. Okay. X squared goes into 3x. So to do that, you say, what do I have to take times x squared to get it to be equal to x to the third? And that we just need another x. And then we multiply. X times x squared is x to the third. x times 0x is 0x squared, and x times 3 is a 3x. We draw our line, change our sign so that we're doing subtraction. Okay, our x to the thirds cancel. We have a negative 5x squared here. The x's, the 3x and a negative 3x give me a 0x, and then I bring down my next term. Now I look at my front terms again and I say, okay, what do I have to multiply by x squared to make it equal negative 5x squared? Well, to get the negative 5, I'm going to have to multiply by a negative 5 up here. And to get x squared, well, I already have an x squared, so all I have to multiply by is negative 5. Go ahead and distribute now. So I take negative 5 times each term and write the result down below. Negative 5 times x squared is negative 5x squared, just like I wanted. Negative 5 times 0 is 0x, and negative 5 times 3 is negative 15. Draw the line and do what? Change the signs. Okay? The 5x squared and negative 5x squared give me 0. The 0x's give me 0. And the negative 15 and the positive 15 give me 0. So I have no remainder. That means that this divides evenly. Okay? So my solution was x minus 5. If they wanted me to rewrite that using the remainder of 0, I would say that x to the third minus 5x squared plus 3x minus 15 is equal to what I divided by, x squared plus 3 times my answer, x minus 5 plus nothing else, because there was no remainder. So it's just equal to this portion right here. Okay, so notice that was one way. It's kind of like factoring, because you are dividing to find the factors. If there's a remainder of 0, then you know that they're factors. Okay, let's try this last one here, and we'll finish up our long division and move on to synthetic division. Okay, so looking at this problem, we set it up once again, checking for anything that's missing. Notice right here, I'm missing the x to the fourth, so I'm going to have to put a 0x to the fourth there. I'm also missing the x squared, so I'm going to have to put a 0x squared. For this term, I'm missing the x term, so I'll have to put a 0x. When I set up my problem, I want to make sure that those things are there. Okay, put my division sign. Underneath what I'm dividing, I am dividing negative x to the fifth plus 0x to the fourth plus, signs in the way, 7x to the third plus 0x squared minus x. And you can put a 0 on the end here just in case we need that, because notice we were missing our constant term also. What are we dividing by? We're dividing by x to the third minus x squared plus 0x plus 1. Okay, so we look at our front terms to start our problem. What do we have to multiply by x to the third to make it equal negative x to the fifth? And the answer to that is we need a negative, and we'll need an x squared, so that we get x to the third times x squared is x to the fifth. We distribute that. Negative x squared times x to the third is negative x to the fifth, just like we'd hoped. Negative x squared times negative x squared is a positive 1x to the fourth. Negative x squared times 0x is a 0x to the third. And negative x squared times 1 is just a negative 1x squared. Draw the line, change your signs. When you have lots of signs, you want to be super careful. I especially want to be careful because it's kind of messy writing on the whiteboard. So notice my x to the fifth cancel. That first term should always cancel, or else something was wrong. I have now a negative 1x to the fourth from changing my sign. A positive 7x to the third, and a 1x squared. and then I bring down my next term, which was negative x. Then I look at my front terms again, and I say, what do I have to multiply for x to the third to be negative 1x to the fourth? Well, I need a negative sign, so I'm going to put the negative, and I need one more x to get to x to the fourth. So I'm going to multiply by negative x, and we distribute. Negative x times x to the third is negative x to the fourth. Negative x times negative x squared is a positive x to the third. Negative x times 0 is a 0x squared, and negative x times 1 is a negative x. Draw the line, change your sign. Positive, negative, negative, positive now. My x to the fourth cancel as they should. I get 7x to the third minus an x to the third is 6x to the third. A 1x squared and a 0x squared is just a 1x squared. And a negative x and positive x cancel, and I have no x's left. Bring down my last term, which was a plus 0. And here is my last time doing this. Okay, I can still divide because I have an x to the third and an x to the third. What do I have to multiply for x to the third to become negative or positive 6? X to the third. Answer to that is a positive 6 is all it was missing. So plus 6 goes up on top and I distribute it. 6 times x to the third is 6x to the third. 6 times negative x squared is a negative 6x squared. 6 times 0x is a 0x, and 6 times 1 is 6. I missed my zeros here. Draw your line, change your signs, and what happens? My 6x to the third, I get 0 there. 1x squared and a 6x squared gives me a 7x squared. My 0x's give me nothing. And on the end down here, I have 0 minus 6 is negative 6. Whew! So here is our remainder. I know I'm done because I have an x to the third, can't go into an x squared because it's a larger degree. Let's write our final answer here. Okay, so remember you go back to the original problem and you say, now I know that negative x to the fifth, if I can see through all my writing, plus 7x to the third minus x is equal to x to the third minus x squared plus 1, what I was dividing by, times my answer, negative x squared minus x plus 6 up on top there, plus a remainder of 7x squared minus 6.